Okay, so let's have a look at the 2020 Higher Level Leaving Cert Maths Paper 2, question 8. So we have an airline company, Trans-Sky Airways. It has designed an aptitude test for people applying for jobs as trainee pilots. The aptitude test is scored out of 500 marks. The results are normally distributed with a mean score of 280 and a standard deviation of 90. The top 25% of people taking the aptitude test are invited back for an interview. Find the minimum mark needed on the test in order to be invited back for interview. So let's just write down what we have here first. We have mu, which is equal to 280. Our mean is 280 with a standard deviation of 90. Now, what we need to do here is look at the top 25% of scores. So if we take our top 25%, let's say is here, we're looking for this here. This is where 25% of the people are. So we need to find this z value here. Now, in order to look up the probability of being greater than this particular z value here as 25%, really we need to look at 75%. We need to look at this area here. So we need to look at all of this area here. Okay, so our tables will be... So these are our tables here. Now we want 75% here, so let's have a look for 75%. Well, we can see here we've got 73%, 74%, 74, 74, 75%. So we have 74% here, 0.74, and we have 0.75 here. So it's going to be somewhere, our z value is going to be somewhere between these two. So the first one is 0.67, and the second one is 0.68. So I'm going to use 0.675, somewhere in between these two. 0.675 will give us roughly 75% probability. So let's just write down our z value here. So our z value is going to be equal to x minus mu over sigma. In our case, we want to work out what x is. So we want to work out what the score would be. So our mean is 280 and our sigma is 90, and we know that that's going to be equal to 0.675. This is our z score here. Now let's just work that out. That means then that what we need to do here is just multiply across by 90 first. So if we multiply across by 90, we'll get x minus 280 is equal to 60.75. And then finally we'll just add 280 to both sides, and that'll give us 340.75. Just to round that to 341 marks. Doesn't ask us to do that, but let's just do that for the moment. Now that just means that the minimum mark needed on the test in order to be invited back for interview will be 341 marks. Okay, part 2. Anyone who scores above the 40th percentile can resit the test later. Eileen scored 260 marks on the test. Find out whether or not Eileen is eligible to resit the test. So let's just work through that. Again, we'll just have a look at our z value, x minus mu over sigma. So in our case, she scored 260, so that's the x value. Our mean was 280, and sigma again was 90. So when you work that out, you get minus 2 over 9, or 0.2 repeated. Okay, so on our standard normal curve, again, we'll have 0 here. Minus 2 over 9 is about, let's say here, minus 2 over 9. So this is where Eileen scored. The probability, we need to look at the probability of appearing down here. We need to look at the percentage of people in this part of the graph. Now we can't look up on our standard normal distribution tables negative numbers. So let's just flip that around to plus 2 over 9 here, and its equivalent area will be here. Now we can't look up greater than, so we've got to look up less than that, which is going to be here, subtract it from 1, and that'll give us this area here. So let's just work through that then. So what we want here is the probability of z being less than minus 2 over 9. That's just going to be 1 minus the probability that z is less than plus 2 over 9. So that's going to be 1 minus, so we got to look up 2/9 or 0.222 in our tables. So let's just have a look at that. So 0.222, well there's 0.2. 0.22 is here, 0.5871, let's say, 0.5871. So that's going to be 0.5871. When we subtract those two, we get 0.4129, which is equal to 41.29%. So that's where Eileen is. She's in the 41st percentile. So therefore, Eileen is eligible to resit the test. So we can write that in. Okay, so that's part 2. Let's have a look at part B1. Explain the relevance of the Z scores minus 1.96 and 1.96 in the standard normal distribution. Okay, so we'll just use the basic definition here. 95% of the data lies between minus 1.96 and plus 1.96 standard deviations from the mean. And that's it, that's really all we need to write there. Okay, so let's have a look at part 2. TransSky Airways surveyed 2,500 of its passengers about a new service it proposed to introduce. The variable p hat is the proportion of respondents in the survey who said they would use the new device. The radius of 95% confidence interval of the survey was 0.01568. Find the value of p hat, where p hat lies somewhere between 0.5 and 1. Okay, so just remember that our population proportion is going to lie somewhere between our p hat minus 1.96 times the square root of p, or p hat, we'll use p hat, 1 minus p hat over n, and p hat plus 1.96 times the square root of p hat times 1 minus p hat over n. Now the radius that we're talking about up here is really just this here. So that's what we're going to use here, and that's going to be equal to 0.01568. So let's write that down then. 1.96 times the square root of p hat times 1 minus p hat over n in our case is 2,500. That's going to be equal to 0.01568. Okay, so we just got to solve for p hat here. So the first thing I'm going to do is divide across by 1.96. So that'll give us the square root of p hat times 1 minus p hat over 2,500, and that's going to be equal to 0.08. Okay, so that's going to be then, what I'm going to do next here is just square both sides. So I get p hat times 1 minus p hat over 2,500 is equal to 0.000064. Next thing I'm going to do is just multiply across by 2,500, and I'm actually going to multiply out these brackets on the top as well. So I get p hat minus p hat squared is equal to 0.16. So what we have here is a quadratic equation. So let's just bring everything over to one side, and as well as that I'm going to change the signs because I have a minus p hat squared here. So I'm going to call that p hat squared. Got to change this to a minus p hat. This will be brought over to this side and become a minus, and then change it to a plus 0.16 equal to 0. We've got to stick all of this into our quadratic formula. Let's do that up here. So we have, therefore, that p hat is going to be equal to minus b, so that's going to be plus 1, plus or minus the square root of b squared, that's minus 1 squared, minus 4ac, so it's minus 4 times 1 times c, which is 0.16. That's all over 2a, so that's 2 times 1. What we get there is 1 plus or minus the square root of 0.36 over 2, and then finally that's just going to give us 0.8 or 0.2. Now remember our p hat then, this is our p hat here. So remember p hat here has to be between 0.5 and 1. So in our case here, our answer then is that p hat is equal to 0.8. That's the sample proportion. Okay, so we have part C here. The weight of the airline passengers' carry-on luggage is normally distributed with a mean of 12 kilograms. The airline has recently introduced a fee for non-carry-on luggage. After the fee was introduced, the airline expected the mean weight of carry-on luggage to change. They selected a random sample of 80 passengers and weighed their carry-on luggage. The sample mean was 13.1 kilograms and the sample standard deviation was 4.5 kilograms. I'll just write that down, I think. So the carry-on luggage weight mean is 12 kilograms. The sample mean is 13.1 kilograms. And the sample standard deviation here is 4.5 kilograms. They took 80 passengers, so n is going to be equal to 80. Test the hypothesis at a 5% level of significance that the mean weight of the carry-on luggage has changed. State the null hypothesis and the alternative hypothesis. Give your conclusion in the context of the question. Okay, so we've got to state H0 and H1. So H0, our null hypothesis, is that the mean weight has not changed. So in other words, mu is still equal to 12 kilograms. The alternative hypothesis is that the mean weight has changed. In other words, mu is no longer equal to 12 kilograms. So what I'm going to do here is just look at our test statistic here. So that's going to be Z is equal to x bar minus mu. So because we took a sample here, our standard deviation is going to be sigma over square root of n. This is our standard error. Now let's just put our values in here and work this out. So we have our x bar, which is 13.1. So we've got 13.1 minus our mean, which was 12. We've got to divide that by our standard error here, which is sigma, which is 4.5. Divide that by the square root of 80. Now, when you work all of that out, you get 2.186. Now, that's our test statistic. That is in the critical region. It is greater than 1.96. So the mean weight has changed. Test the hypothesis at a 5% level of significance that the mean weight of the carry-on luggage has changed. It has changed. The mean carry-on weight of the luggage has changed. So let's just write that in here. So our conclusion then. So we're going to reject the null hypothesis. We're going to reject the null hypothesis. Okay, so let's have a look at part D then. The company bus can carry passengers up to a total maximum weight allowance of 3,000 kilograms. The weight of passengers is normally distributed with a mean of 73 kilograms and a standard deviation of 12. So again, our mean is 73 kilograms. I'll just write this down. Standard deviation is 12 kilograms. 40 passengers board the bus. So I presume n of here is going to be 40. Find the probability that the total passenger weight will be over the maximum weight allowance. Give your answer as a percentage corrected 2 decimal places. So the first thing we're going to do here is just take our 3,000 kilograms, which is the maximum amount allowed on the bus. I'm going to divide that by 40, because there are 40 passengers on the bus. That will give us 75 kilograms. 75 kilograms. So find the probability that the total passenger weight will be over the maximum weight allowed. So let's have a look at this 75 kilograms. We want to look at the probability that x is greater than 75 kilograms here. So that's going to be equal to the probability that z then is going to be greater than. We've got to convert this to a z value. And again, it's going to be x bar minus mu over sigma over root n. So it's going to be x bar. So our x bar here is 75. This is the mean weight of our, we're taking this as the mean weight of our, the maximum mean weight, if you like, of our 40 passengers. So that we're going to subtract the mean, which is 73. We're going to divide that by sigma, which is 12, over the square root of 40. This is our z value. So when you work that out, you get, let's see, the probability of z being greater than 1.054092 and so on. So this is what we've got to look up in our tables. Now, if you take again your standard normal curve, and you take the mean here, 1.05, let's say is here somewhere, 1.05 and so on. We want to find the probability of being in this part of the graph. Now again, we can't look up in our tables greater than this z value. We've got to look up less than. It'll give us this, the probability of appearing in this part of the graph, so we've got to subtract from 1. So this, in other words, is going to be 1 minus the probability of z being less than 1.054092. So this is what we're going to look up. So let's just grab our tables again. So we've got to look up 1.05. 1.05. Well, there's 1.0. Let's go out to 5. And it is 0.8531. 0.8531 to 4 decimal places anyway. 0.8531. So this is going to be equal to 1 minus 0.8531. And when we subtract that, we get 0.1469. So that's equal to, let's say, 14.69% as a percentage anyway. Okay, so what have we done here? What we were asked to do was find the probability that the total passenger weight would be over the maximum weight allowance. So we first here worked out the maximum average allowed weight, if you like, for our 40 passengers. And we found that the probability then that the bus with 40 passengers will be above the maximum weight allowed is 14.69%, or 0.1469. So this is the probability that the bus with 40 passengers will be above the maximum weight allowed. Okay, so let's have a look at part E. So we have a list consists of 8 whole numbers. They are labelled from A to H as shown below. The numbers are all greater than 0 and are ordered from smallest to largest. The difference between the two adjacent numbers is 2 or more. The median of the list is 12.5. Okay, so they give us a certain amount of information here, and I just want to work through these as we go along. So the first thing they say is the difference between any two adjacent numbers is 2 or more. I think that's about the last thing we're going to use. We use that at the very end. The next one is the median of the list is 12.5. So we can see here we have 8 numbers. That means we have 2 middle numbers here. So the median is going to be then these 2 added and divided by 2. So in other words, we have D plus E divided by 2 is going to give us 12.5. That's going to give us then D plus E is equal to twice 12.5, which is 25. That's the first equation that we may be able to use later on. Okay, second thing then, the lower quartile, the median of the 4 lowest numbers of the list is 7.5. So if we look at the lower 4 numbers, the median of these 4 is 12.5. In other words, if we take B plus C and add them, divide by 2, we get 12.5. So let's do that. So if we take B plus C, divide by 2, we will get 7.5. So that just means B plus C is going to give us 15, multiply across by 2. The interquartile range is 12. The interquartile range is 12. So that means if we take Q3 minus Q1, our answer will be 12. Now we have Q1. We were told that the lower quartile is 7.5. So we have Q1. So that means then that Q3 minus 7.5 is equal to 12. So that means then that Q3, our upper quartile then, is 19.5. 19.5. So we know then that if Q3 is 19.5, if we add F and G and divide by 2, we'll get 19.5. So let's do that. And we know that G is 23. So we're going to take F plus 23, divide by 2, our answer will be 19.5. So let's double that then, double both sides. F plus 23 is equal to 39. So that will give me then F is just going to be equal to 16. So now we know what F is. F is 16. So we can just put 16 in here. So let's see where we can go from here. We have the interquartile range is 12. We've just done that. The second largest number is 23. We have that. The range of the list is 21. So that would just mean then that H minus A is equal to 21. The mean of the list is 13.5. The mean of the list is 13.5. That means if we add all of these up and divide by 8, we get 13.5. That means if we multiply 13.5, if we take 13.5 multiplied by 8, that'll give us all the numbers added. So 13.5 multiplied by 8 is 108. So this is equal to the total, all added if you like. Okay, so let's see what we have here. We have F, and we have these equations here as well. So let's see what we can do with these. Now we can see that we have B plus C, we have these 2 added. We have D plus E, we have these 2 added. We can also add these 2, which means we can work out what H and A are added by subtracting it from this here. So let's just work through that. B plus C, so what I'm going to do really is B plus C, which is 15, put that here, plus D plus E. D plus E is 25, plus F plus G, which is 16 plus 23, 39. So if we add all of those up, we get 79. So now what I can do is say 108 minus 79 is going to be equal to what we get when we add H and A, because we've added all of these up. We know that they all, from A up to H is 108. So if we subtract all of these added from 108, that'll give us H plus A. 108 minus 79 is 29. And that's equal to A plus H. Now remember, I have H minus A. Now I have an equation with A plus H in it. I'm going to put those two together and do a kind of simultaneous equations. So I have H minus A is equal to 21. I have A plus H is equal to 29. These are two equations that I can add. So A minus A will just give me 0. H plus H is 2H. And then over here we have 29, 21, that's 50. That'll give me then finally H is equal to 25. So if H is equal to 25, I have A plus H equal to 29, that's here. So that will give me, let's move this up a bit, that will give me then A plus 25 is equal to 29. That'll give me A is equal to 4. So I have H and I have A. A is 4, H is 25. So I have two more numbers. So I have A is 4 and I have H is 25. Okay, so let's work out the other ones then. Now what I'm going to do is just have a look at these two first, okay, D and E. D and E. Now I know that D and E add to give 25. D and E add to give 25. So let's pick the two numbers in the middle. Let's take 12 and 13. 12 and 13 will give me 25. But it says up here as well that two adjacent numbers cannot be less than 2. Adjacent numbers, in other words, are 2 or more. So 12 and 13 is not going to work. So we've got to get rid of these. 12 and 13. So let's look at 11 and 14. 11 and 14. Now they are 2 apart. 14 is 2 apart from 16. So they'll work. If we pick the next two down, let's say 10 and 15, well 15 is going to be too close to 16, so that won't work. So the only option really is 11 and 14. Okay, let's look at these two now, B and C. We know that B and C give us 15. So let's look at numbers that give us 15. Well, we have 7 and 8. So let's say if we put 7 and 8 in there. Well, again, 7 and 8 are not 2 apart. So 7 and 8 is not going to work. So let's look at 6 and 9. 6 and 9. Well, 6 and 9 will work. 6 and 9 are more than 2 apart. 9 and 11 are 2 apart, so that's fine. 4 and 6 are 2 apart, so that's fine. So these will work. But what about 5 and 10? 5 and 10, well 5 is 1 away from 4. 10 is 1 away from 11, so they won't work. So the only possibility will be 6 and 9. So that's really all of our numbers. And that's what we were asked. Find the numbers which satisfy all the above conditions and write them into the boxes below. So that's it. And in fact, that's it for this question.